Okay. So let's go ahead and open this up. And we will go to screen share. Okay, so I'm just gonna do a quick little overview of finding roots, okay? That's what we were gonna work on today. So this says, find the fourth roots of z equals negative root 3 over 2 plus 1/2 I. So if you notice, this is in rectangular form, right? You can tell because there's no cosine or sine, okay? Let's look at this equation real quick. So we have the root, nth root of z is equal to the nth root of r times, in big brackets, cosine theta over n plus 360 over n times k plus I sine theta over n plus 360k over n. Keep in mind this is the polar form, right? Okay, so remember we're trying to find the fourth roots of this z. And let's go over some of these variables real quick. So r, we can find that using Pythagorean, and that's just something that's in the polar equation. Theta here, we're going to also have to find that later as well, but that's the theta that's made from this complex number here. The n is the root that you're taking. Okay, so here we're taking the fourth root, so that'll give us n to be 4 here in a second. Okay, so let's move down here to the first step, which you should always do when, well, it's highly recommended that you do. So what I did was I took the complex number here and I just graphed it basically. So keep in mind this is your x, and the y always goes with the I. You can kind of remember that because it rhymes, right? So the x is negative root 3 over 2, so I went over to the left, negative root 3 over 2. And the y here was 1/2, so I just went up 1/2. Graph the point, and then I just went from the polar origin, okay? Or I guess you could say the rectangular origin as well. Okay, so if I'm gonna get this equation going, I need to find r and theta. So I'm gonna start with r. So remember, to find r, we can always use Pythagorean theorem. X squared plus y squared equals r squared, okay? So the x here, remember, was negative root 3 over 2, and the y was 1/2 right here. Okay, so I just plug those in for x and y, then I square them. So when you square fractions, you always square the top and the bottom. So that's what I'm going to do. So square root of 3 squared, all that does is get rid of the square root. So it'll just leave you with 3, and then 2 squared is 4, right? Squaring top and bottom. The negative will go away because you're squaring. So it leaves you 3/4. Then you come to the 1/2. So square 1, it's 1. Square 2, that's 4. Gives you 1/4. Okay? So r squared equals 3/4 plus 1/4. Then we have r squared equals 1. Well, to solve for r squared, you just take square root of both sides, and that gives me plus or minus 1, right? Square root of 1, 1. So there's r. So we found r to be plus or minus 1. So we're going to leave it there for now, and we'll decide later what we want r to be, positive or negative. So the next thing, right, we need a theta. So keep in mind, we were given an x, or why don't I say, we were given a y and an x, right? Well, let's think about it. What trig function deals with y and x? Tangent theta. Okay, so come here to step 3. So we have tangent theta equals y over x. Now remember from up top, right? This was our x and this was our y, so we can just plug those in. So here's my 1/2, and here's my negative root 3 over 2. So notice I have a 2 in the denominator here, and then a 2 in the denominator here as well. So because of division, those two will just go away. That leaves me negative 1 over root 3. You know, just for our sake, I think it would be easier for y'all to see this. Let's forget about this step here. Okay, so what we want to think is, what theta value gives me a positive 1/2 over a negative root 3 over 2? So if you go to your unit circle, let's draw this, you'll find that point, so we want a positive 1/2 for y. So that's going to be up here, right? 1/2 up there. And then we want a negative value for root 3 over 2. So these are special trigonometric ratios. So there is a special angle that goes with it. And that angle is 5 pi over 6. Okay? So we come down here, you'll notice we have 5 pi over 6. Okay? And that's the only one it can be, because from our graph earlier and the given values, it said that y had to be positive, so positive 1/2, and x had to be negative. So I can only be in quadrant 2, and 5 pi over 6 is in quadrant 2. So that's how we know this is the only one. Okay, so let me clear all my drawings. So for our sake, I'm going to leave it in degrees because it's a little easier to work with complex numbers in degrees. You'll see that excuse me, here in a second. Okay, so let's go to part 4. Okay, so n equals 4. Remember, that comes from the fact that we were looking for the 4th root, right? That's how we get n. It comes from which root you're looking for. Okay, so that is n. So now let's go here. If you notice, now we are literally just in a plugging in fest, right? So we're going to have n equals 4. We found r is equal to plus or minus, so let's talk about that. So I'm going to pick r to be positive, and that's because if you notice, when it comes to polar degrees, this is the degree I rotated to 5 pi over 6. And so if I'm going to get to this point, my r has to be positive. I have to go a positive r distance or positive 1 distance here. Okay, so I'm going to pick r to be positive 1. All right. So let's go back to part 4. So we said n is 4, r is going to be 1, and theta is going to be 150. Now keep in mind, I'm getting this equation from the equation we had up top. The root n, r, all this stuff. And I'm just plugging in now because I found r, theta, and n. Okay, so 1's going to go here because that's our r, and it's the 4 because of n is the 4. Then we go cosine theta, which we found to be 150 degrees from the work we did in step 3, divided by 3. That is incorrect. That should be a 4. I'm sorry. But that's a 4. Okay? That's because n is 4. All right. Now that we fixed that, 150 divided by 4 plus 360, that comes from the equation, divided by n, which is 4, times k. And we'll get to k here in a second. And then the sign is the exact same thing, except there should be an I here. Okay. Remember, because we are in complex numbers. Okay, so from here, it was going to be y'all's job to simplify this and then find Z0, Z1, Z2, and Z3. But since it's just me, I'm going to do my best to write this out. It's a little tricky to do it. So I'm going to write it out via text. So if I simplified this equation, it's going to be, remember, let me move this up a little bit so we can see. Remember that we had the 4th root of 1. Well, that's just 1, so I'm going to leave that as a 1. Bracket. So we have cosine of 150 divided by 4. I don't believe that works out nicely, so let's see what it is. 150 divided by 4. That's about 37 0.5 degrees. Okay, and then we have plus, let's do 360 divided by 4. Oh, that's a nice little 90 degrees. So we got 90 degrees, K. And then I'm just going to do the same thing with sine, but we're going to have an I out front. Sine 37.5 plus 90K. Let me extend this real quick. Parentheses, bracket. And this is the simplified polar form so far. Okay, so now you may be wondering, what is this Z0, Z1, Z2, Z3? So that is what we're going to use in relation to K. We're going to take this subscript here. We're going to take this subscript here, and we're going to plug it in for K. So let me show you that. I'm going to do 1, and then we'll be done. So Z sub 0. That means we're going to have K is equal to 0. It's going to look like this. So we had that 1 out front, right? So I'm just going to go ahead and not write it because it's just 1 times anything is itself. So we have cosine of 37.5 plus 90 times 0. Keep in mind I'm plugging in 0 because that's K, right? That's why I'm plugging it in. So in that parentheses plus, extend it, plus I sine 37.5 plus 90 times 0 in bracket. Okay, so this is what the equation would look like for Z sub 0 when I plug in 0 for K. Notice that the 90s, so those are just going to go away, right? So what you're going to be looking for is just this. Okay, so let's plug that in. Do I have those buttons? I do. So cosine 37, cosine. That's about 9 degrees of radian. I'm in radian, degree. So 37.5 cosine of that. It's about 0.7933. That just seems so weird. I guess it's not actually, because that's a little bit bigger than 30, which is root 3 over 2, which is a fraction. Okay, so 37.5, take the cosine of it, you're going to get about 0.79. I should say I'm putting it into rectangular form. And the way you put it into rectangular form is by just finding these values and distributing your R. Okay, so putting it in a rectangular form, we have Z equals about 0.79 plus, let's find sine of it. So we have 37.5 sine is about 0.61. And that is the first root, or one of the roots from our polar equation that we had up top, which was Z equals negative root 3 over 2 plus 1/2 over I. So remember, the first thing you want to do is graph it, right? And you graph it from the equation they give you above. The second thing you need to do is find your R, because that's in the equation. I should use my, find your R, because that's in the equation. That's what we did here using Pythagorean. The third thing you need to do, find your theta, and we do that by using tangent theta, because remember, they gave you y and x up here. Okay, so reduce that, eventually you'll get an angle, and you decide that angle from your picture, right? So we're in the second quadrant, so we pick 5 pi over 6 for our theta. Fourth step is you just plug in. Okay, so we found n, we found r, and we found theta. So we just plug that into the equation that we got from up here. Okay. Plug in, reduce, and this is what we got. I distributed the 1. Now the Z0, Z1, Z2, Z3, that is just telling you what your K value is. Okay, so we just found Z sub 0. I plugged in K equals 0, and so that just canceled out the 90. I found those values, and this is now the rectangular form of one of the Z's, Z sub 0. And keep in mind, you have to do this for all of them. So you basically would just be plugging in 1 for K here, and then when you found Z sub 2, plug in 2, Z sub 3, plug in 3 there. All right. The last thing I'll say is that sometimes you'll get a value bigger than 360. Once that's the case, just keep subtracting 360 until you're within 0 to 360 degrees. Because remember, you have angles that are the same. All right, guys. Hope you have a great Thursday. Good luck on your test, and this will be available for you.